Hello everybody, this is Kiran Patil, working as assistant professor in Department of Computer Science and Engineering, BLACET, Vijaypura. I hope all of you are doing well by staying at home. Now, today we shall discuss regarding the clipping algorithms. Now, before we go into or dig deeper into the various algorithms that are used in order to clip the object. First, let us understand what clipping is all about. So, a two-dimensional point clipping goes as follows. For a clipping rectangle in the standard position, we say a two-dimensional point p is equal to x comma y for display if the following inequalities are satisfied. That is, if x is greater or equal to xw min, or if it is less than or equal to xw max. Similarly, y greater or equal to yw min, or less than or equal to yw max. If any of these four inequalities is not satisfied, the point is clipped, that is, not saved for display. So what does this mean? This means that any point on the object, if I name that point as x comma y, if its x value lies between xw min and xw max, that is, the minimum value of x for the clipping window and the maximum value of x for the clipping window. Similarly, if y lies in between yw min and yw max, that is again the minimum value of y for a clipping window as well as the minimum value of y for as well as the maximum value of y for the clipping window. If these conditions are satisfied, then the point would be displayed. That means that point would be accepted in order to get displayed onto the screen. If any of these four conditions that are listed above, if they are not satisfied, it means that particular point is being rejected for the display. All right. Let us take an example here. As you can see, we have a clipping window where you can see this. This is the clipping window, and we also have number of line segments, which of course are indicated with points such as P1, P2, P3, P4, P5, P6, P7, P8, P9 and P10. Now you can observe that some of the line segments completely fall inside the clipping window, whereas some are completely outside. Whereas there are some line segments which are partially inside the clipping window and partially outside the clipping window. That means the line segments which are completely outside are rejected to be displayed, and the line segments which are completely inside are accepted to be displayed onto the screen. Now this is what the clipping window does, right? For example, you can see P1 and P2 line segment. As you can observe, that P1, P2 lies completely inside the clipping window, and hence it gets completely displayed onto the screen. Similarly, if you see P3 and P4, as it is observed, P3, P4 are completely outside the clipping window. That means they are rejected from getting displayed. Similarly, we have P9, P10, which is again completely outside and hence rejected. Now, what about those line segments which are partially inside and outside of the clipping window? Now, for that, take an example here, the P5 and P6 line segment. Now, as you can see, P5, P6 line segment is lying partially inside the clipping window. The point P5 is clearly outside the clipping window, whereas point P6 is completely inside the clipping window. That means here, as you can see in the next figure, figure number B, we have to find out an intersection point with the clipping window. And we name it as P5 dash. Right? Similarly, if you take another example of the line segment, which is P7 and P8, as you can see, P7 lies outside the clipping window, whereas P8 also lies outside the clipping window. In such a scenario, you are supposed to calculate, you're supposed to estimate the intersection point at both ends. For example, as shown in the figure number B, we have calculated the intersection point P-7 and P-8. Now this is how we choose the part of the line segment that needs to be displayed onto the screen by finding out the intersection points with the clipping window. Now, in order to do this, we have many algorithms that are proposed. One such algorithm is as you can see is Cohen-Sutherland line clipping algorithm. Now, how does this Cohen-Sutherland line clipping algorithm works? It's very simple. Here in the Cohen-Sutherland line clipping algorithm, we use something called as region codes. Based on the region codes, it is decided whether the point would be rejected or accepted by the clipping window. For example, you can see that we have 4 bits starting from right to your left. You can see the first bit, bit number 1, represents the left. Bit number 2 represents the right. Similarly, bit number 3 represents the bottom. Bit 4 represents the top. So this is how the region codes are decided. Right? So for more clarity, let us look at the region codes of the clipping window, or the regions that are supposedly besides the clipping window. You can see the region code for this particular region is 1001. That means it is the top left corner. It is the top left corner of the clipping window. That means bit number 1 is set to 1 and bit number 4 is set to 1. That means bit number 1, which represents the left, is set to 1. Similarly, bit number 4, which represents the top, is set to 1. That means that particular region lies top left of the clipping window. Similarly, the region code for this particular region would be 0001. That means it lies exactly to the left of the clipping window, as you can see in the diagram 2. That means only one bit needs to be activated, that is bit number 1. Bit number 1 represents left. Similarly, the region code for this particular region would be 0101. That means, as you can see, it lies towards the left bottom of the clipping bit. That means the left bit is set to 1 as well as the bottom bit. So bit number 1 and bit number 3. Similarly, the region code for this would be 0100. That means it lies exactly to the bottom of the clipping window, and hence only the bottom bit is set to 1. Similarly, this code would be 0110. That means it is towards the right bottom of the clipping window, and hence right bit and the bottom bit is set to 1. Similarly, the region code for this particular region would be 0010. That is, it lies exactly to the right side of the clipping window, and hence only the right bit is set to 0. Similarly, the region code for this particular region would be 1010. As it is self-explanatory, it lies towards the right top of the clipping window. Similarly, the region code for this particular region would be 1000. That is exactly at the top of the clipping window. Now, based on these region codes, it would be decided whether the line would be accepted, or a point of an object would be accepted, or the point of an object would be rejected for display. Alright, so I'll stop my video lecture here, and in further videos we shall discuss regarding in detail about the Cohen-Sutherland algorithm. Thank you very much for your patient listening. Have a healthy life.